If you have not signed in to Meetico, please do the little scanning up here. This is how we know how big of a room to have and such like that, is that they count. And apparently we've been undercounting in the past. So if you scan the QR code, that will log you into Meetico. Well, it'll get you on the process of logging into Meetico. So let's give people we'll start 2 minutes late, given that we're in this obscure corner of the room, of the hotel. So Sophia, it was like they said, oh, let's put these people in the basement in the corner and such like that. So I'm assuming it'll take people another minute or two to get in, but then we can get going. Actually, and go ahead, Sophia, you can go ahead and put up the chair slides now. So even though we've lost the QR code up there, blue sheets being passed around, which only has a QR code. There's also on the front door. Very good. Oh yeah, no, there's plenty of ways to do it, but people have been failing university, so we just want to get this going.
Okay, shall we go ahead and start?
We've got a couple people streaming the door. Give people about 10 seconds to get a seat. Actually, it was just the AMS people wanting to know if I was drowning yet, and the answer is no, I'm fine, thank you. So take it away, Sophia.
Okay, so thank you, Paul. So thank you everybody for coming to our working group. So this is the PQUIP working group at the IETF 117. Just to note here, please, this session is being recorded, and the results of this recording is going to be posted in YouTube. So please be aware of that. As you may know, all of you already, if you already participated in other working groups and other IETF meetings, we have a notewell, this is just a slide, which is a reminder of the different IETF policies that we have in effect on various topics, such as patents and code of conduct. So if you're interested in any of those, here are all of the important links. So check them out if any of them are of your interest. And I wrote note really well. Please note that all of the IETF meetings and mailing lists are intended for professional collaboration as it is defined in the IETF guidelines for conduct. And we also strive to create and maintain an environment in which people of different backgrounds and identities are treated with dignity, decency, and respect. We do have a code of conduct, so please behave in a professional manner. And if you want to read in more detail any of these, you can check also online the notewell. Just some meeting tips again. Again, the session is being recorded for in-person participants. As Paul was just saying, you actually need to sign up into this Meeteco because if you actually want to join the MyQ, you will have to do it through the application. So please do so. I'm afraid I don't have any more the QR code, but you can find it somewhere else. And please do sign up. Please, for the person who are remotely, keep the audio and video off for the majority of the working group session, unless if you are indeed presenting or if you are talking. And lastly, some other resources. If you want to know about the agenda of the whole IETF, you probably know this link, some information about Meeteco, and if you need technical assistance, there's also the link in the slide. And finally, just the final kind reminders of our working group. Again, the session is being recorded. The recorded version of this session is going to be uploaded into YouTube. We do need someone also to be the note taker. So if any volunteers want to right now be the note taker for this session, please state so.
Hold on. Raise of hand. Who would like to be a note taker, please?
Or in the chat as well.
Or in the chat, but we really could use one. It's a good way for you to test your typing skills. Thank you, Flo. Yeah. And again, all we really want is the mic line discussion. You don't need to repeat what speaker said. So Flo has said yes. Thank you.
Okay, perfect. Thank you very much, Flo. Again, please use the Meeteco queue. If you want to be part of the mic, please sign in through the Meeteco. And also remember that we follow the IETF Code of Conduct, which is listed in this slide. And with that, welcome again to the Post-Quantum Using Protocols Working Group. This is a working group that is chartered in the IETF to document operational and design guidance which supports the PQC transition. If you want to read more of our charter, basically use the link in the slide. And also, if you want to join any of the discussions, please sign up for the mailing list that is also in the slide. Finally, just to give you a recap of what we have been doing, the status of the working group at the moment is that we have one working group item, which is going to be presented, the status of that working group item into this meeting. And if you want to check it out, this is basically the post-quantum, the hybrid terminology draft. And it's right now a working group item. So for today, basically what we have the agenda, the intro and well that I just went through, then we will have an update of the hybrid terminology document. We will have also an update of the PQC for engineering document, an update on this document that is not really a draft or an RFC, but basically a list of the working groups and protocols looking at the post-quantum algorithms currently at the IETF. We will also be talking about real deployments of post-quantum cryptography, and we will hear the experiences of Google on deploying post-quantum cryptography, and updates from the LAMPS working group on their efforts on post-quantum cryptography, and then any other business. And just prior to moving on, is there any agenda bashing that right now people would like to state that they would like to talk about anything? This is your time.
I'm not seeing anyone in the room. Oh, wait, we've got Michael. Michael?
It's not so much an agenda bash, Mike Burrock here, sorry. But just under the all other working group business, can we make sure we have a touch on test vectors and cross coordination between all of us working on drafts at labs, COSE, etc.?
Yep, I'll start that.
Perfect, that sounds good. Yes, so with that, Flo, I think you were going to be presenting the hybrid terminology document, if I'm not wrong. Yes, there you go.
Correct.
Okay. I'm going to then share your slides, Flo, as well. There you go.
Actually, so here's my first failure. Sophia, if you're doing the slides, does her clicker do anything, or she will have to
Let's
ask you?
try. Can you try the clicker? No? Doesn't work. I think you will have to share their board.
Okay, so then I share here. Daddy's here to help. Thank you. I knew this was going to happen. Look, actually, no, that's true. Given our age difference, it's the kid who understands the tech better than the old dude.
Daddy's fair. I'm going to stop this thread. This isn't going to end well for either of us.
Oh, and they have a small subset of the slides.
So if you need a refresh,
I certainly do. Okay, very good. Thank you. I can wing this. Yep. Okay, here we go. Okay, and then so now you apparently are in control. Oh, wait. Why is it not then sharing? Right. So it just brought that up in a different window.
Yeah, so there should be.
I am.
Share preloaded slides.
Got it. Sorry, that was a different one. There we go. Got it.
Excellent.
We're okay. I think good is an overstatement.
Excellent, I think. Let's go with that. Cool. Thanks, everyone. So yeah, I'm here to present the terminology for post-quantum traditional hybrid schemes, which was adopted at IETF117 by this group. So the only... I'm not sure the clicker's doing anything. Next slide, please.
Oh, I don't seem to be controlling it.
I'm pressing all the buttons. I'll keep talking. So the update to the draft since then is just an update to make it a working group draft rather than a personal draft. But there has been some discussion on the mailing list, and there are a few topics that I wanted to discuss today to get contributions on before we iterate to a 0-1. So the context here, as I think most people probably know, this is an informational draft which is standardizing a kind of glossary for post-quantum traditional hybrids. So we mean solutions for key agreement or for signatures which use both post-quantum and traditional algorithms together. Aims are there, ensuring consistency across different groups in the IETF, but also hopefully more broadly, but also making it clear what security properties a particular hybrid construction claims. And I think particularly in the signature space, we're starting to see more proposals which have different security properties. So having the language to describe that is really important. And it's clear we can draw from academia there as well. Yeah, so I kind of 3 things I want to discuss today. Maybe they're on the next slide, please.
Okay, that's useless. I know how to click.
So yeah, to discuss agreement on the base definitions, this came up on the mailing list, a question about splitting the draft, and also a kind of call for what's next. So I'll go through all of this. If you have any clarifying questions, please do jump in the mic line, or if you think anything I've said is like really wrong. But for kind of more general discussion, we'll wait until the end, if that's okay. Cool, next slide, please. So the draft starts with a sort of basic definition section, and I think it's important that we get these right because all the other definitions are based on them. And the kind of the simplest 3 of those are traditional algorithm, meaning an algorithm which is like based on either integer factorization or discrete log. Post-quantum algorithms and also post-quantum traditional hybrid schemes. There's kind of some questions about this language in meetings. So I sent a message to the mailing list asking if people were happy with these as the base definitions. There are a small number of responses. The responses there were basically positive, but there were some tweaks which I'll make, but they're basically positive. So I guess what I'd like to ask this group is I would like to now bank these and say we can go ahead and kind of define the more interesting language. But I wanted to open that up today as well as on the mailing list. That's thing 1. So the next question was about splitting the draft. So when I first introduced this at Sec Dispatch, there were one option that was proposed by a few people was splitting the draft in 2. So to form 1 draft on terminology for hybrid chems and 1 on terminology for hybrid signatures. I think the reasons given, the main reason for this is that we expect the chems discussion to be more straightforward. So a chems draft could potentially be published more quickly. But also because the kind of progression of chems and signatures in the IETF is different paces. So the terminology work could mirror that. I think the kind of the arguments against splitting this is I think there'd be quite a lot of duplicated work. Quite a lot of the language is either the same or very similar. There's also a risk that we all sort of give up when signatures come along. And I think that's actually, the language is harder, but therefore it's arguably more important for that reason. And then there's also this potential for lack of alignment. I guess my proposal would be that we keep them together. I think it's going quite well, but it's not my draft anymore. This is a decision for the group. So opinions on that would be really welcome. And then the final thing was, so I think this draft has got, I think, a decent structure. There's been some additions suggested on the list recently by Mike, which I think are really good suggestions. But I guess just kind of asking the room, like, what are we missing? Can we do some testing against the protocol drafts to see if this language actually makes any sense? Like, what do you need for this to be useful? That's basically it. So I think that's pretty much everything I had. Get in touch. But yeah, I guess any comments, thoughts, questions, very welcome.
Please get in the queue if you want to speak to the mic. And certainly we hope to be hearing from people who have drafts where this is used. So Jonathan?
Hi, Jonathan Hoylands, Cloudflare. Unfortunately, I haven't had a chance to read this draft, but is the idea that we would use it like the not must, like I am using the terminology of RFC whatever it is, 10,000?
I mean, I guess less strictly than that. So it's not kind of normative language where if you use it, it must mean what it means in that draft.
Well, as in, if I say in my RFC, I am using the terminology as in draft 10,000, then we don't have to worry about other people using it differently because I'm just being clear that I'm using this version.
Yes. Yes. So yeah, there's no forcing anyone to use this language, but it gives somewhere to kind of root that language. So yes.
Which is one of the reasons we'd like to move this forward a little bit quicker so that it can be out before some of those others.
Sounds good.
Yeah,
Thank
thanks. Phil?
Yeah, actually, I was going to say that in terms of the progression, I mean, it's important to get started on this first, but, you know, this is a terminology draft, so I would expect that we're going to be developing the terminology as we're developing other stuff.
Mm-hmm.
And so, you know, I would keep it all as one, simply because it's not going to be one of the first things that comes out. It's going to come out with the first thing at the earliest.
Yep, great. Sean?
I just got booted out of the queue.
Oh.
Mike Ainsworth.
Yep.
So I can speak to the suggestion I made on list recently, if that's a welcome. So I noticed this paper by Nina Bindel and Britta Hale. We actually have the author back here. Hello. And it made some really nice suggestions around properties that you might want out of your hybrid, specifically signature. Different gradations of non-separability properties. They define the term true hybrid. And those seem to me like really useful concepts. We're having a lot of debates about, and I've seen them more in the chem space, but they're going to also show up in the signature space, what protocols actually need. If you have a certificate, then can you accept weaker properties out of your crypto primitive? If the protocol doesn't have certificates, it just has pinned keys, then maybe you need stronger properties out of your primitive. And I thought this draft would be an amazing place to define those terms so we have a common understanding of what the properties are that we may or may not want in a given protocol.
Actually, Mike, before you step away, since you are the author of a draft or two, which would be using this in LAMPS, if I remember correctly, how do you feel if this draft takes a while to finish in order to get all of that right versus timing for getting your draft out? I mean, that's one of the things I would love to see folks in line saying is finish this now and rev it later or whatever, or take your time and get it right. Do you have a feeling on that?
I guess my personal opinion is I don't know what finished means. Language evolves. I'm quite happy to keep my drafts in lockstep with version X of this draft. Every time I rev the LAMPS drafts, I bump the version number and update my language where it's been adjusted. That's
okay.
Fine by me.
Okay, thanks. Sean.
Hi, Sean Turner. Don't make work for yourself. I understand it's a working group draft. Don't split it, leave it in one. I think it'll be easier. Basically, I have the same answers that he did about the drafts. The other drafts that I'm writing in LAMPS, we'll just keep it in lockstep. Let's do it.
Great, thanks. Rowan.
Hi, Rowan May. So as I heard Phil talking, I was thinking that there may be a difference between this is all the hybrid terminology that we might want to talk about, and here's a set of just like basic hybrid terms that we want to be able to use now. I think this draft is trying to address the latter. I think that would be really useful because I think we can actually move forward, and I think we could actually progress some documents to get some working experience with some basic things, you know, hybrid chems, for example. So curious what people think there. I would be very happy to have a set that is not the end all be all set of everything that we want to talk about, and still also have some of those other terms defined in another document.
Great, thanks. Aaron.
Hi. Also in the OpenPGP like working group, we have a draft that we are so far not planning on splitting. So it's perfectly fine for us if you keep it together. And second, I also think we are now referring to the draft as still actually your personal draft. And it would be fine if it takes a while to standardize.
Great, Thanks. Aaron. Oh, sorry. Sophia.
Yes, this is mostly a reply to Mike. So I did read also the paper, and it's a quite great paper, but I think what this draft aims to do is a little bit different in that it's more interested in about the specific terms to use rather than the cryptographic definitions and properties. I think that for the latter, it will be an effort of a research or academic effort. First, get a consensus around that and get the research completely right prior to putting it in the IETF document. So centralizing this draft into more the common terminology that we use rather than the cryptographic properties seems like a good place to start prior to actually looking at any formalization of mathematical properties.
Okay, thank you. And oh, we lost connectivity. So Michael, you're last, and then I'll try to figure out what to do about connectivity.
Perfect. Sounds good. Yeah, thanks, Flo. This is actually very helpful. I don't mind the draft taking a while. I'm also not a huge fan of going ahead and hybridizing all the signature schemes, but I understand why some folks feel the need to do that. And so if they are going to do that, we should make sure they name stuff properly. In particular, thinking of conversations yesterday in the COSE working group, especially around HPKE and things like that, being able to get good naming and consistent naming for signature schemes or for HPKE schemes would be quite helpful, because then it's providing guidance to the working groups as to what to do. So I think keep it all in one, since there's so much overlap in the guidance. And if it takes a little while, it takes a little while. The one thing I would say, though, is if it is going to take a while, we should make sure we are broadcasting to groups that are, defining these things so they're aware of it, right? There are still folks that aren't necessarily paying attention to some of the drafts over here, this one included. So.
Thank you. Other people in the front of the room have lost connectivity, or is it just me? Okay, so Sophia, so we are done. Thank you. I think you have enough to do. Sophia, can you take over slides and such?
Yes, Paul, also Lorenzo says that there's an Ethernet cable on the desk that you can use instead of Wi-Fi, if you're interested.
That's just, yeah, maybe. Have I ever used Ethernet on this machine? Why, no, I haven't. So if you do the next one, we will find out whether Ethernet works.
Okay, perfect. Then we have the next presentation, which is post-quantum for the post-quantum for engineers document, which is a document that has found some work lately. So I think Tim was going to present this. Where's my presenter?
So who's doing the PQC for engineers presentation? It's being done remotely. Okay.
Okay.
Oh, right. We knew that. So let me see if I actually have connectivity now again. Oh, okay. Sophia, can you get them out of the queue and let them do it? Or let me see. Let me just.
So is Tim going to present? Sorry.
Thank you. Oh, and I do have connectivity again, so not that we bet that this will last forever, but.
All right, Tim Halbeek said I can talk to Sophia without, and she can actually hear me.
Okay.
No, I'm not actually going to present. The presentation is going to be done remotely by the person who's in the queue right now. So if you can get them.
So, yeah, let me just present the slides. And Arita, you can unmute yourself. Share preloaded slides. Share. Okay.
Okay. Yeah, there you go. Okay.
Hello. Hello. Yeah.
Yep, we are hearing you now.
Yeah. Thank you everyone for joining this session. As as explained, it's actually, I think it was discussed at length at, I think, IETF 117 as well, the post-quantum cryptography for engineers. This is personally my first IETF presentation. And so we have the authors here from Amaritra. We have Tiru, we have Dimitrios from Nokia, and we have Tim as well from, and I think Tim is in the room as well. So yeah, next slide, please. So why is this draft relevant to PQUIP? So it's actually explains why engineers need to be aware of and understand post-quantum cryptography. And it emphasizes how cryptographically relevant quantum computers are going to affect the current cryptographic systems and the need to transition to PQC algorithms to ensure security. Now, an important point to note here is that not much cryptographic math will be discussed in this draft, but rather an overview of the post-quantum use in protocols. Yeah. Next slide, please. So this is the general contents of the draft, how basically the draft, the flow of the draft works. And we'll not be going through each of this basically points in this slide because we have limited time. But essentially the draft actually covers a lot of aspects from what cryptographic primitives can be replaced and what's the correct timeline for transition using Mosca's model, and capping it off with the security considerations and how are the recommendations for security and trade-offs between PQC and classical. Yeah, next slide, please. So essentially, I think we are all quite aware of this impact of quantum computers in cryptography. Asymmetric cryptography is considered to be broken because of Peter Shor's algorithm for finding an order of an element. Basically, it solves the order finding problem, which is essentially, again, solving an instance of the hidden subgroup problem in finite abelian fields. And so, and for symmetric crypto, you have law of Grover, who shows how to search, basically brute force an unstructured search with root n complexity, so basically a quadratic speed up, but doubling the key sizes theoretically ensures that it's supposed to be quantum safe. I stress on the word theoretically here. And so, yeah, next slide, please. Yeah, as explained in the previous slide, Shor's algorithm, basically it solves discrete log as well as the factorization problems in RSA that we have, which is, again, an instance of the hidden subgroup problem for finite abelian groups. And it actually works for multiplicative, which is essentially used for a finite field. Discrete log problems, or additive, which is used for the elliptic curve problems. And the effective algorithms include but are not limited to, well, RSA, ECC, CDH to begin with. Next slide, please. And symmetric cryptography, we mentioned that theoretically it does require us to double the key size, but there have been some research ongoing for quite some time that basically doubling the key size will not provide any significant gain in actually cracking the symmetric key. And since Grover's algorithm is highly non-parallelizable, because it provides a quadratic speed up anyways in a single quantum computer, so basically parallelizing it won't offer significant gain in cracking the key. And NIST still standardizes AES-128, which is also the first level of security for post-quantum protocols. Yeah, next slide, please. I think this is an interesting attack, or I think it's called different names. It's called store now decryptlator, or privacy monitoring, or harvest now and decryptlator. So an attacker can basically record your session, and they, in the handshake phase, they can actually obtain obviously the public key, and they can use Shor's algorithm to get the private key, and that private key is basically used to get basically the shared secret that can be used to extract ultimately the plain text later on when a quantum computer or cryptographically relevant fault tolerant quantum computer becomes available. Yeah, next slide, please. Two primary cryptographic primitives that are being now discussed are, of course, key agreement schemes and digital signatures. Again, because these are based on integer factorizations or finite field discrete, and these will be vulnerable to Shor's attacks. Next slide, please. In the draft, we also mentioned, this is from an engineer POV, how to understand the non-interactivity and the difference between KEM and how Diffie-Hellman-Kex works. And as such, in Diffie-Hellman-Kex, as you can see, both the client and server have can generate a secret key and a public key, and they're not the public key is not, or the shared secret is not dependent on sharing a ciphertext between the server and the client, and each can compute individually using the other's public key. But from a KEM perspective, it's essential to note that first the client sends over the public key, and the ciphertext, which contains an encapsulated key as well as the shared secret, is then the ciphertext is sent, and then the client basically decapsulate the shared secret using its ciphertext and secret key. So essentially diminishing the non-interactivity of the Diffie-Hellman key exchange. Yeah. Next slide, please. Yeah, I'm not going to go too much into details about HPKs. The RFC 9180 deals quite extensively on how the different modes of HPK and how you have an optional mode for possession of a KM private key. But the important point to note here is, next slide, please. Yeah, the Kyber, which is a PQC KM, they currently do not have the support for the static ephemeral key exchange in HPK based on the DH-based games, which Kyber doesn't support at the moment, and it's quite discussed extensively in the draft section that we have mentioned here. Yeah, the next slide, please. Now, overall, these are some of the, well, these are not some of the, these are basically all of the, I think that would be the right word to say at the present moment. So for NIST candidates selected for standardization / the candidates advancing to 4th round. So for KEM, you have Crystal Kyber, which is of course based on the hardness of module ring learning with error problem. You have Crystal Dilithium, which is also again based on the hardness of the structured lattices. You have Falcon, which is a signature, but that's based on the hardness of shortest integer solution in the NTRU lattices. And of course, you have a Sphinx Plus, which is hash-based signature, which is based on HORS hash to obtain random subset trees. And essentially lattice-based cryptography and, yeah. And hash-based signatures have been right now finalists, but for the 4th round, we have some really interesting candidates from the code-based cryptography area. For Bike, Classic Michaelis uses GOPA codes, Neterator's public encryption, and of course, Hamming quasi-cyclic codes. And of course, we unfortunately had the cyc algorithm super singular isogeny exchange, which was unfortunately broken last year. And so we want to stress on the fact that isogeny-based cryptography is not broken. There are many interesting SQI sign or other signatures that are currently available, but this particular algorithm was unfortunately broken. And the signature part, as you can see, is empty here because there were some additional signature rounds that was basically formulated by NIST. And I think a few days ago, there were around 40 to 50 new signatures that was actually released by NIST for an additional signatures for the 4th round. Yeah, next slide, please.
Just as a note on the last part, there were 14 or 15, but that's already been winnowed down. Like daily,
Okay.
we're seeing like, oh, no, that doesn't
yeah,
work.
Oh God, yeah. Yeah, I've seen the mailing list, the group, yeah, the mailing group list, yeah. So the security notion for KEM and signatures, as we are quite aware, the KEM, we need to be secure for in CCA to attack, and Kyber, Bike, Classic Michaelis, they do provide this attack. And for signatures, you need existential unforgeability so that an adversary cannot basically forge your signature and spoof. And Dilithium's Falcon and Sphinx Plus, they all provide EUF CMS security. And these are interesting points to note from an engineer's point of view. Yeah, moving on. Yeah, so I'm not going to go into the entire details of this standardization timeline, but this is more of a reference that we have. We had some interesting the competition started in 2016. There was a workshop in 2015, and well, here we are right now in 2023. Next year, hoping to have the first standard. Yeah, moving on.
Just noting that the June 1st has come and gone.
Oh yeah, that's gone. Yeah. Yeah. So Mosca, interestingly, in 2015, gave a very interesting report on the basically he published, I think, a threat report was published, and how to assess if you're not in the area of cryptography and post-quantum cryptography, how to assess how the migration would affect your company or your products, or basically anything that uses asymmetric cryptography. So we have an X, which is the time which we want to keep our system secure. I mean, let's say that's quite a lot. We do want to keep our system secure for quite some time. Y is the time which we need to deploy a quantum safe migration plan, and Z is basically the time which is required to build a large scale, say, fault tolerant CRQC. Now, essentially, if X plus Y becomes greater than Z, then secrets get revealed. There's a security gap here. So ideally, X is not essentially under a person implementing X is not under their control. Z is also not under any individual's control. The Y is something that depends from person to person or from use case to use case. And I think from a bigger picture, Y is something that needs to be mitigated such that X plus Y becomes less than equal to Z, because that would be the ideal scenario. Because unfortunately, from a company perspective or somebody working individually, you don't have quite a lot of say in how X and Z would evolve actually throughout the time. So it's essentially the Y which we need to focus on. Yeah, moving on. In the draft, we also mentioned a few of the stateful hash-based signatures as well, just to compare with Sphinx Plus, and they do have a cryptographic security issue where you can, if you use the secret key, it actually has a lot of problems, and it's quite explained extensively in the drafts that we mentioned, the extended Merkle tree signature and the latent Merkle signature scheme. And so we'll not go too much into details right now on this. Yeah, moving on. Hash then sign. I think most of the PQC signature schemes, they internally apply this hash then sign feature. So we do not need to worry too much about it, but it's essential. And protocols like TLS and DNSSEC, they also use hash then sign. And they actually, I mean, the hardness is reliable on the basically the collision resistance or the pre-image resistance of the hash function. Yeah, moving on. Yeah, so these are some, well, I'm not, it's going to take some time to go through the table. So I'll just give some key points here. So these are the security levels that has been laid out by NIST, and it's defined basically as a function of the resources that you might need to break AES or SHA-3 algorithms. So in case of AES, it's the optimal key recovery, or for SHA-3, you have the optimal collision attacks. Now, engineers or users can leverage the required algorithm based on the security level, based on their particular use case. So you have Kyber 512, which has the AES hardness for AES 128. You have dilithium 2 for SHA-3 256, and so on. But unfortunately, we didn't find any security level for level 4. We'd be happy to welcome some suggestions if anybody has any idea about level 4, if there are any current algorithms that are working in that level. Yeah, moving on. This is, well, again, generic key and ciphertext signature sizes and how they differ according to the different security levels. As you can see, which would be quite obvious that as you see the security level increases, the public key size and the signatures of ciphertext sizes increase drastically. Yeah, moving on. Now, Sphinx Plus gets a special mention in our draft. It's the same public can see for the same security. Plus, so we do have a few lines in the draft. Basically, some we didn't think of putting in a table of different. I mean, the time taken for signature generation, because there's different systems. People use different systems for different tables. So we wanted to have a consensus on how these actually work and how how basically is how many signatures per second it happens on different systems. So that was there would have been some basically different opinions on different machines. So we didn't get too much into details of that, but we do mention that dilithium is usually used for the fast signature generation, and Falcon has lower key and signature sizes and more efficient signature verification. If you have access to, of course, 64-bit floating point integers, floating point, not so, yeah, and the Sphinx Plus, of course, offers smaller key sizes, but when compared to dilithium and Falcon, they have larger signature sizes and slower verification and signature generation. Yeah, moving on. Yeah, I touched a bit on this topic on the last slide. There's some challenges in Falcon signing operations. I mean, you need access to 64-bit floating point operations to avoid side channel vulnerabilities. And doing this correctly is actually quite difficult, as a report by NIST recently noted. And I think this year in the real world PQC, there was some presentation by the authors where a masked implementation of Falcon was also seemed infeasible. Yeah, moving on. This table actually helps engineers understand the key sizes, like when they want to implement between traditional and post-quantum algorithms, and how for each security level the sizes increases as compared to, say, for example, in X25519, you can see the public key size changes from like 32 bytes to 800 bytes. And I think this comparison is essential to understand basically the amount of cryptographic agility that would be needed for the migration. Thank you. Moving on. And we have the similar for PQC versus traditional signatures in the draft. I won't be going into details of this. Yeah. Next. Yeah. Now, keeping in line with Flo's draft, we do have PQT hybrid confidentiality. We've kept that term. Now, this is one of the interesting topics that have been that's been discussed quite in other working groups as well, where it's to protect from the harvest now decrypt later attack, and you have a concatenate scheme, and you also have a cascade hybrid scheme. The concatenate hybrid scheme is basically there's a draft recently on TLS 1.3. Basically, you concatenate the two shared secrets from a post-quantum and a traditional algorithm together, but it does not actually address hybrid authentication. There's another scheme which recently became an RFC. It has for IETF2, it has a cascade hybrid scheme, but it's essential to have at least one traditional scheme, as mentioned here, the elliptic curve Diffie-Hellman, and it allows the negotiation of one or more PQC algorithms. Yeah. Moving on. Now, this PQT hybrid authentication is something which is also being discussed in the LAMPS working group to use PQT hybrid certificate, but the frequency and duration of how and when to support PQT authentication is still under some discussion. And this essentially protects from an on-path attacker or a man-in-the-middle attacker who has access to a CRQC. Yeah, moving on. Yeah, and so we have some essential discussions in the draft as well for hybrid mechanisms and how you can combine the single classical algorithm with multiple post-quantum algorithms, and why it's essential to have the AND mode rather than the OR mode, because in OR mode the security of the weakest algorithm is basically the strength of the entire algorithm. So essentially, it's more important to have the AND mode, where you have at least one classical and at least one post-quantum algorithm, which can be more, the post-quantum part. Yeah, moving on. And yeah, when combining keys, it would make more sense to have a single composite keys instead of two keys. And so from an engineer perspective, a composite algorithm is composed of two algorithms, which is basically fused to be a new algorithm. And so support for adding new algorithm, the cryptography agility, they already generally exists. Yeah, moving on. And and as discussed, many of these points are still being actively explored and discussed, and the consensus may change over time, but it's essential to understand that if we are using a simple thing as concatenation or hash and concatenate, we have to ensure that the lengths are constant or they're fixed, essentially. Otherwise, there would be some security concerns. Yeah. Moving on. I'll briefly go through here. We have some security considerations from PQC and classical perspective as well. So classical perspective, you have the mathematical vulnerability attack, you have the algorithm attack, and you also have the side channel attack. And but from quantum computer perspective, CRQC perspective, the attack is mainly on the specific mathematical problems, and they both pose a threat to the security of the algorithms. So developing new cryptography algorithms for long-term security is quite essential. And yeah, moving on. Yeah, cryptographic agility from an engineer point of view, it's very essential to have this point because these threats are rapidly emerging, and I think as you can see, it's like every day you have some new discussion going on. So it's very essential to have a sort of cryptographic agile system where you can adapt to the emerging threats and plan for long-term security in the face of rapidly evolving cryptanalytic techniques. And the first standards, hopefully by next year, would ease and help in the introduction of PQC and help basically in the transition. Yeah, moving on. Yeah, hybrid key exchange. So basically this bridges the gap between post-quantum and traditional cryptography. So the PQC algorithms are selected they're relatively new as compared, I mean, not the maths behind it, of course, but the algorithms in itself they have not been subject to the same depth of study as traditional algorithms. And there would be certain deployments where you have to retain traditional algorithms due to FIPS compliance. And the hybrid scheme basically would enable potential security against harvest now decryptor or pervasive monitoring. Yeah, moving on. Yeah, so that brings me to the end of the presentation. Please, comments and suggestions are welcome. And thank you to all the reviewers who have already provided feedback and comment. We've received quite a few reviews. So thanks for that. And the draft is being collaborated in the link provided. And yeah, so any questions?
So thank you, Rita. So queue is open. Even though we aren't, it's hard to contribute on a long document like this in a room here. This is, at least in my mind, I think Sophia agrees with me, one of the primary outputs of this working group, because it's less technical than what we typically do. We want what we do in the IETF around post-quantum cryptography to be accessible in other places. This document's going to be heavier than, like, you won't necessarily be able to give it to everyone in your organization and have them understand it, but hopefully everyone will be able to go through the introduction and skim through the rest to start recognizing what you're doing. So as we get more discussion on the list, at some point we are going to hit the maximum of what should we put in. We may have already hit that. That would be a very valuable thing to hear on the list about how complete are we, how complete should we be. One thing that came up early on was, well, this is already beyond how I can, like, I can't give this to somebody who's non-technical, and the answer is correct. I have been unfortunately having to give this, talks about this to very non-technical people, and quite frankly, there's no reason for an IETF document to be aimed at them. But many of these non-technical people who are interested in post-quantum cryptography have technical-ish people around them. And we would love it if this document was at least 50%, maybe 80% readable by a technical-ish person who's been told to learn it for somebody who's less. That would be excellent. So please do read the review, please do look at it from that standpoint. Do reviews. Feel free to have other folks in your organization do a review. It may be over their head, but they can still contribute, to it. So we've got a couple people in line, and then I'm going to close the queue because we've sort of hit the time limit. But please, we've got 3. So Phil.
Yeah, it might be useful to talk in terms of risk, in that we do not know when somebody's going to build a cryptographically relevant quantum computer. I did physics once. I think the probability is probably less than 1% in a decade. But if they build it, they bring down the banking system. And a 1% chance of bringing down the banking system is something that we've got to guard against.
So there is stuff on that in the draft. If that's your particular concern, by all means, drill in on that and propose wording. Some of the parts of the draft are written correctly, but by people whose it's not their focus. So if that's your focus, absolutely drill down, propose wording.
Yeah, that's the hook that I use to light up people who are non-technical.
Yep. And many of us work in organizations that have risk managers. See what they think. Tim?
Yeah, I just wanted to follow up on some of the things that Paul said, which are absolutely 100% correct. I made the same appeal in Yokohama. Please do read it, engage. It is very hard for those of us, if you're sitting in this room, it says PQC for engineers, you're at IETF, you're probably an engineer. You are the target audience for this document. It's a long document. There's a lot of text. If some of it doesn't make sense to you, please ask questions. I'd like to see a lot more interaction. It is very difficult for those of us who know this stuff to understand what this reads like to somebody who's new. I've been following this stuff very closely for 5 years. A lot of this stuff is very obvious to me. It's not very obvious to people who have not been following this for 5 years. We need more help with a lot of these documents. There's a very small number of us trying to solve these very important problems. The purpose of this document is get as many engineers in the world up to speed on these vital issues as quickly as possible. So help us help you. Thank you.
Thanks. And for those who didn't know, Tim's one of the co-authors, and John?
Yeah, it's John Gray from Entrust. I just wanted to say thank you for putting this document together, because I've basically been doing this type of presentations for many different people for the past 3 to 5 years. So having a document that we can point to that basically covers everything, encompasses everything in detail like this is great. And just one quick question, was this adopted?
Yes.
Okay, good. Because I was going to say, if it wasn't, we're
Actually,
definitely.
I don't know. I'm saying that awfully quickly. Okay,
Is it
so if not, then
if it's not adopted, let's adopt it.
So yeah, Sophia, are you taking notes since I can't type right now? But yeah, if we didn't, we should by now, and we will do that soon. Assume it is adopted. At this point, I can't imagine that we wouldn't adopt it, given the strong desire. Oh, AD interruption.
So I think the idea was precisely to do the call after the IETF. So we should start the call after this IETF.
Yep, sounds good. We'll do that next week. Yep, very good. Okay, thank you. Next up is, Sophia, you have a slide on our grand one.
So the next should be quick. I think I can just share. You have to stop sharing, but I think I can force.
Okay, well then why don't, here, see, stop sharing slides. I really do feel like an old guy up here with everyone else knows how to run this except for me. So yeah, right. It's called aging. So please, yes.
Okay, so this is going to be a quick presentation because I know that this is related a little bit to the agenda bashing that we mentioned at the beginning of the meeting. So as you know, we're also developing this document, which is not going to become an internet draft nor an RFC, but it's basically a GitHub link README where we have listed the efforts of different working groups in regards to post-quantum cryptography. And of course, you can find the link on the slide if you want to check it. So more than anything, now it has been actually been populated with a lot of resources, but the question here is if we're missing something or if you want to see something specific, then now is your time to actually let us know so we can try to continue that effort. I know that there was also the question about the test vectors, so this is the time to discuss that precisely. So you had some ideas on that, Paul.
Yeah, so just briefly, this is, for as long as we're a working group, this will be alive. If we stop being a working group at some point, this may turn into something else. But for now, it's a GitHub repo, meaning you can suggest things on the list. You can suggest things in the GitHub and such like that. The reason why this is fairly valuable, at least our view is one of the parts of our charter is to help other working groups in the IETF coordinate. The best way to coordinate is to see lists of other working groups that are doing stuff like you. And so that's one of the reasons we have it. We've got a couple people in the queue. Rowan?
Hi, Rowan May. So I wanted to draw your attention. I had made a pull request to add work that's being done, discussed in MLS, which is an MLS Safer Suite that uses post-quantum hybrid key exchange mechanism. So
I assume you did
FYI.
the pull request in the last hour and a half?
Yeah,
Yeah,
30
okay,
minutes.
fine. Thank
Okay.
you. I was going to say. Yes. Good. So, but just as a note, this would be for the people who thought they knew everything. We now have MLS on the list as well. So, John?
Yeah, so I was just gonna kind of follow up to that. So if we want to add to the list, we should just do a pull request? Is that the preferred
However
way?
you want to do it.
Or we ask the chairs to add
You
it,
don't have
or-
to ask.
'cause there's stuff I want to add.
A pull request is great. If you want the working group to see what you're doing, stick it in, like say something on the list. This is not meant to be the only place to look. And if you're putting something on the list that says this would go in there, you might say why. I just discovered this, or we're not sure about this. It's fine for the working group mailing list to be a discussion list of how is this going in the other working groups in the IETF.
Great.
Yeah.
Thanks.
Yeah. Well, thank you. So, Mike.
I'm having a lot of trouble keeping my phone on the Wi-Fi. You will allow me to?
Yep.
One thing I want to point to this document that's not immediately obvious is at the bottom, there's a list of IETF protocols that do not require any action. And I have had many conversations with people saying, when is HTTPS going to be updated for PQ? The answer is it doesn't need to be. It inherits crypto from somewhere else. And so this document is sort of an IETF approved list of things that you do not need to worry about.
It's not
I think
IETF
has
approved.
value.
It's very
IETF,
informal.
Okay, I'm sorry. I backpedal on that. But an IETF working group associate. Anyway,
Yeah.
something to point people at as sort of proof that, no, you don't need to go patching your HTTPS or
Right.
whatever else.
Right. So feel free to point other IETFers at this page, especially if they're like, do I need to worry? They might see one of the working groups they care about on it. If they don't, they might ask a question of, is this something we need to worry about and such like that. But like, as we heard, once one of us gets off of our laptop, MLS is going to appear in that list as well. There may be more coming over time. That's great. We have a funny bit in our charter that is not related to having a document that comes out of it. This is a way for us to do coordination. And if you think of other things that should be on the list that aren't just drafts, there should be a discussion of this or whatever. Say it on the list. If people like it, great. It will go on as well. It's freeform. It's a pile of markdown. So great. Okay. Next up, Sophie. That would be you. So now you need to stop sharing, Sophia.
There you go.
And that is you. I am sharing, and you are you. Please.
Yeah. Hi, I'm Sophie Schmiek. I'm work at Google for IC Crypto. Sorry?
Either that or you can do you can either be a rock star and walk around, or you can do that. Okay.
I will try to not be a rock star.
Okay.
Okay. So yeah, I'm Sophie Schmiek. I work at Google at IC Crypto, where we have been deploying post-quantum cryptography in the last like 3-ish years on our internal encryption in transit. And I wanted to share a bit of the things we've learned and hopefully help us to apply some of the things to the larger effort of having post-quantum cryptography rolled out. Okay, this slide is something that we've kind of seen already in the last few talks. Why do we care about this right now? I don't think I'm giving away any new information here. That the main thing to care about is the store now, decrypt later attack of like having someone store encrypted information now, and when a quantum computer becomes available, actually being able to decrypt this information. Next slide, please. So from this, the priorities that we have at Google and that I think are more or less shared with the larger community is that like encryption in transit is a thing that needs to be fixed more or less as soon as possible. With like the some details of like what we can fix at what point, given that we kind of want to have standards for a lot of these things still being out. Signatures are sort of the secondary thing when their public key is hard to change. So if you have like firmware signatures, for example, for secure boot, where your public key is in silicon, you kind of want to work on your transition plan now, because who knows how long how long this device is supposed to live. It might be 10 years or more. So at that point, it becomes a bit dicey. As another point on signatures, and that also goes into this all other asymmetric cryptography, especially when it comes to standardization, encryption in transit is somewhat easier, in my opinion, than signatures, just based on like, for encryption in transit, there's really not that many protocols. There's like, yeah, SSH and TLS, and you have like a lot of things already covered. Whereas signatures are somewhat all over the place. And signatures are probably going to be the much harder part of actually transitioning here, where we should probably, when it comes to standards in particular, start soon and not just get distracted by this list of priorities. The last point on this list is symmetric cryptography. We've seen it before. I very much follow the same logic of like Grover's algorithm is unlikely to actually be possible on a realistic quantum computer anytime soon. So we don't really need to care about symmetric cryptography all that much. AES-128 should still be very much fine. Next slide, please. Okay, this is the part of the talk where I abuse the fact that I have the microphone for 15 minutes and just give some of my points of hybridization and how this should be done in my opinion. So one of the problems that I'm seeing with hybridization and some of the discussions that already have been happening is that if you do hybridization in a naive way, you end up multiplying the amount of cipher suites that you end up with by a huge amount. Like each hybridization of two schemes should be seen as its own cipher suite. And so if you allow any arbitrary hybridization, you end up with like the product of all of the cipher suites that you have. I don't think that is a good idea. I think that that makes the system much more complicated. It increases implementation complexity, and it sort of gets away from like cipher suites having a well-defined role in the system. So I do think that we should, wherever we can, have like as few as possible cipher suites. And that means making a hybridization decision for the cipher suite and moving on and not trying to combine everything, especially when it comes to signatures. This came up previously already here. I don't think that we like if whatever we are working on at that point doesn't need Falcon, for example, we should just not have Falcon in there. Like just keeping it simple, I think, is one of the biggest problems that we otherwise might run into. We have like historic examples like PGP having tons of different cipher suites, and then you have implementations that support like non-overlapping parts of these. We have the nice thing with what TLS did, where from 1.2 to 1.3, it actually mostly removed stuff. And I think that was a very good idea. I think keeping things simple is very, very useful. Okay, next slide, please. Okay, now to the actual topic of the talk of how we rolled out PQC at Google. There's this wonderful slide that someone made a few years ago about our internal infrastructure that shows how our internal infrastructure works. So we have this central Google front-end server that deals with all the web requests. That was always was HTTPS for a very long time. And then behind that, there was our intranet. And before this slide happened, things were not always encrypted on that side. The nice thing about having this kind of internal intranet thing that has its own encryption in transit that isn't really a standard is that it allows us to iterate on that fairly easily, that it allows us to experiment on things there without much effort. And so since we sort of control all the implementations of this, we just try to see what happens when we add PQC to this internal encryption in transit system called IETF. Okay, next slide, please. So as a quick overview of how the protocol works, if you've seen HPKE or any other chem-based or any other elliptic curve-based protocol, this is a fairly straightforward ECDH, static ECDH. There's a version of this protocol that uses ephemeral keys as well, and then ends up with forward secrecy. For simplicity's reasons, I will focus on the non-forward secret protocol for this. The main reason that we have both is that some of our workloads have a lot of requests coming in to the point that they can't really afford the forward secrecy. So looking at how this works, we have first the client init message, which sends the static ECDH key with its certificate to the server. The server then can send its own static ECDH key alongside with its certificate, and at this point can already compute the shared secret and send a confirmation of that shared secret over. And the protocol, the handshake protocol, finishes with the client confirming this shared secret. So this is a standard protocol, what you do when you have an authenticated ECDH key. The alternative would be TLS, where you have an ephemeral ECDH key and need to sign it. In this case, the ECDH key is already authenticated and part of the certificate. Next slide, please. Okay, so this has one important alternative flow. In the case that this is a resumed connection, we use resumption tickets, stateless resumption tickets that are encrypted by the server. And so to do that, the client will send its static ECDH key and everything, just in case the resumption ticket turns out to be bad. Alongside with this resumption ticket, which is the key that the server has encrypted for itself before. And the server can now decrypt this resumption ticket and check that it actually can decrypt this resumption ticket. If it is successful in decrypting this, it will confirm that it resumed this session, not send its credentials because that's not necessary because it's a resumed connection. So we already checked the credentials previously, and the rest of the flow is remains the same. Okay, next slide, please. So this is the main problem that you get into when you do PQC. If we look at IETF before adding anything PQC related, you can see, I made these little boxes where every box is 1 byte. You can see how bad this gets. An X25519 key share is 32 bytes protocol overhead, and even the certificate isn't that much larger. Even if you use RSA, it's 4 lines instead of 1 line. and so on. So it's fairly compact. If you compare that to, in this case, HRSS, because that's what we had from the Cloudflare experiments from years ago, and we started this before Kyber was chosen, otherwise we would have used Kyber already. Then this gets very large. There's like more than a kilobyte of data in the handshake message now. Same is true for Kyber. The sizes are very, very similar. So the main problems that you run into are with the size of this handshake package now. Next slide, please. So how did we add this? Like our first approach to doing this was, well, let's just add an ephemeral PQC key to the client init. Server can encapsulate to that key, and then we just add this to our shared secret derivation. And then we have a very simple hybrid scheme that gives us quantum security, but not quantum authenticity, because I kind of hope that nobody is currently running around with a quantum computer impersonating servers, because that would be bad.
It would also be wasteful.
I mean,
they should be decrypting with that.
If they want to be man in the middle, then maybe. I don't know. In any case, so assuming that there's no quantum computer right now, this gives us protection from store now, decrypt later. It doesn't, like, if there's a quantum computer, then this wouldn't be secure. Like, then this could still be broken by man in the middle attacks. Next slide, please. So the first issue that we had is that this ephemeral public, the ephemeral PQC public key was sent with every single request and created with every single request, which is somewhat wasteful if you're otherwise doing a static exchange. So the first thing that we had to do was to make this key a bit cached. Otherwise, the flow is the same. But if you cache this key for 10 minutes, you don't get quantum forward secrecy anymore, but like we don't have forward secrecy in this flow of the protocol in any case. So why bother with quantum forward secrecy was the idea. Next slide, please. So the problem is that even with that, we kind of accidentally, like this is the resumption flow again, this kind of accidentally introduces forward secrecy into resumption. While forward secrecy on resumption is a big topic that we should have more of and should discuss more, because still, like even in TLS 1.3, it's technically optional to do that. This kind of introduces, again, forward secrecy to a flow that didn't have forward secrecy before, and we learned the lesson of why we didn't do forward secrecy on these workloads, because people got mad at us. But otherwise, this works perfectly fine. The fix is fairly straightforward. You just don't do it on resumed connections. The resumption secret is derived from the session secret anyway, and so you already have the same quantum protections on resumed connections, save for all the forward secrecy discussion, but that is independent of PQC. Okay, next slide, please. Okay. So the whole thing took us about 3 years from starting with the project to now. And like part of this was really a bunch of mistakes that maybe we could have seen coming, like things like adding forward secrecy to a flow that kind of intentionally didn't have forward secrecy. There was also quite a few bugs that we discovered in our implementation just by having it at scale. One thing that happened was a literal stack overflow, like not that there was an array that wasn't bounce checked, but that the stack was too small to contain the keys because the keys got so large. Other things, like we had various small bugs that we needed to fix along the way as well. So one thing to certainly keep in mind is that cryptographic implementations are very hard to do correctly. and it will take us some time, even now that we have like Kyber and so on, and once the standard is out, it will take some time to have these implementations to actually be on production quality so that we can roll it out. The next takeaway is the threat modeling is kind of important. You want to focus on encryption in transit as a fast thing to fix. So you want to do that as soon as you can and just have some ephemeral keys riding along with the handshake, and otherwise not care too much about how the rest works. But you also want to, especially when you're working on standards, start working on the other parts of PQC as soon as you can, because it's going to be complicated. Like adding quantum safety against store now decrypt later attacks for TLS is fairly straightforward. There's like draft standards that do that already. Doing the same thing for signatures is going to involve some hard discussions. It's going to also be a good opportunity to actually like maybe make X509 a little bit less scary. So like,
good luck with that.
we have an opportunity here. Like it's not so like the main reasons that nobody wants to touch X509 standards right now is that why would you touch something that works right now? If it doesn't work anymore, we could actually make it better. I can't really say what better looks like, but I think X509 isn't going to find many people who like it. So
the two people who like it might be in this room.
I'm very sorry to those two people. Yeah, so that certainly is a point that as a standards committee is very much something to appreciate, that signatures are going to be much more complicated than just the additional encryption in transit or HPKE even. And we should take the time to do that and do it right and try to avoid some of the mistakes that we've made in the past and learned from, hopefully. And the last thing is that, yeah, hybrid deployment is great and allows us to do these things without too much risk. But keep in mind the things that I said as well about hybrid also has the potential of just exploding the amount of cipher schemes that you have very quickly, and making a system more complicated without the need of it being more complicated. Okay, next slide, please. Yeah, that's all that I had, and I'd like to thank you for the attention and for the
We have time
invitation.
for just a few questions. We still have one more presentation. If folks have questions, get in the queue. If not, I think your email address was on the first slide.
I think so.
Nope.
No, it's not. It's first initial last name at google.com.
Right. So not seeing anyone in the queue. Thank you very much. And then, so is it Tim or Russ, or Tim and Russ? Okay, and then we find you, and you just had like one slide, right?
Yeah, there's just one slide.
Yes, it says one here, so there we go.
Yes. All right. This is just going to be a quick update on what's going on in LAMPS for those of you who don't follow it that closely. It has been a lot of very complicated and very lengthy discussions over a number of years. Some of actually the discussions that have gone on in LAMPS actually ended up in PQC for engineers. So there's actually a lot of, if you are very interested in a short summary of how hybrid has gone, there is actually a section in PQC for engineers that discusses some of the same things about, hey, is generic composite a good idea and things like that. And, totally agree with the last speaker. Be careful about just allowing the entire universe of combinations. There's lots of people. That's an idea that's going to get resuggested over and over and over again, and it's still a bad idea. But anyway, as far as the stuff that's actually going on at LAMPS, there's a lot of these things turn out to be relatively small and straightforward once you figured out the right way of doing them, which is great. That's sort of how engineering is supposed to work. So the first one is actually a great thing about how post-quantum cryptography will work for CMS. And so that's the chem redraft that Russ is writing. It's in working group last call right now. He's been resolving comments as quickly as people can throw him at him, but they haven't given up yet. I think he will tire them out pretty soon. So I've got good feelings about this working group last call, but that's what's going on there. The PKICs and CMS updates are actually pretty straightforward. We've got most of that figured out. Most of the issues are still, we don't have OIDs from NIST for the algorithms. And so that should be resolved later this year or early next year. And that will unblock a huge number of things. So as soon as there's an official NIST approved way of saying this is dilithium, that will be great. So that's sort of the end state. A lot of the work in labs has been around transitions, and crypto transitions are always the hardest part. The end state and the final state are much easier. And also, we've discovered along the way that chems are a lot easier than signatures. I think everybody's noticing that these days. So the composite chem draft, composite is like hybrid, but instead of trying to put 2 keys into a certificate and try to figure out how that works, composite says the best way, it's very similar to the other stuff that people are doing. The best way to to consider a pair of a traditional and a post-quantum algorithm is to actually see it and put it together and just have it as one blob. So you have just one algorithm and one key, and that works a lot better with a lot of the tooling and infrastructure. So there's a draft that shows how to put keys together for the purposes of using in a chem. And so that's just recently adopted. So watch that one if you want to follow how that's going. A lot of people instead want to avoid all this hybrid and composite stuff and just run 2 parallel PKIs and transition between the 2. That is a perfectly reasonable approach. There are some questions about if you are running 2 parallel PKIs, how do you sort of make sure nobody's playing games with which certificate matches which certificate. So there's a draft about that if you want to follow sort of the emerging discussion about what's the best way to do that. There are some serious challenges there. Especially because of the fact that on the traditional side, all of your cryptography is eventually broken, right? So one of the 2 pairs will never be able to have a strong binding to the other, and how much you care about that is a matter of debate. The last thing I wanted to say is there was a lot of discussion around the adoption of the composite drafts. The composite chem stuff moved forward. The composite signature draft did not advance. But that doesn't mean the idea is dead, or you can't talk about it at LAMPS anymore, or you can't talk about it at IETF anymore. It's really just there's more work needed. It turned out to be a lot harder than a lot of us expected it to be. And so I think the best thing to say about composite signatures is it's an area where, please, if you are interested in it, additional thought and analysis would be very helpful. We still don't really have a good idea of how a transition will work for signatures, even though the end state for signatures is pretty straightforward. So that's the updates for LAMPS. If people have questions, more than happy to answer them.
You can enter the queue or you can go to the LAMPS meeting, but
yeah, that works.
If you have any questions that are relevant to non-LAMPSy people in the room, open. That was Russ yelling, "Thank you, Tim." So good. Okay, thank you, Tim. So swapping back here, I think. Yep, please.
Yes, just the last things. We will start, as we said, some call to actually the adoption of the post-quantums of engineering draft. So expect to hear that, and please participate in the mailing list after that. I don't think we have any other business at the moment.
So we did have the question about test vectors and such like that. My suggestion would be to use the catch-all document, on GitHub as a place to start. If that gets too complicated, we can do a draft or whatever. Drafts of sample keys and such are interesting, but they can be great or they can be awful. But I would say maybe just start at Sean Turner's at the mic, and He's shaking his head.
No,
No.
I was going to say about keys and stuff. I
Yeah.
just asked Baz for some keys and he pumped them out for me. So he's got a script where he can make like hybrid keys and the whole 9 yards. But what I was actually getting up was to ask the chairs if you could update the about page for this working group to make sure the GitHub repo was listed. I had some trouble finding it. There's a way to press the buttons. And
Yep. Okay. Sophia just went like this. So, yep. Thank you.
We also have Russ in the queue.
Oh, sorry.
Sorry.
No, Russ behind you.
Yeah. Roman can go first. No problem.
Sorry again, Wi-Fi. I can't make the magic work. We have a PQC related draft coming up in Sec Dispatch much later this afternoon, and I can't tell whether Yov is in the meeting, and so I wanted to plug for him to just say something if he is in the meeting about the draft we're going to talk about in 2 hours.
He's not popping into the queue, but if he does, then he can. Oh, there he goes. Yoav, why don't you jump before Russ just because you were just given an introduction.
Okay, so I just want to make sure that people...
Yeah.
Oh, I just asked Yoav to get ahead of you, Russ. So
I'm sorry.
All right. Yoav, so take 2 minutes to tell us what's going to happen in Sec Dispatch about your draft.
So there's a draft that's actually an amendment to Mike's hybrid signature draft, which makes a different scheme of hybrid with slightly different security properties. And going to discuss this and probably get told to take this to CFRG or something. But that's the expected.
And that's in Sec Dispatch,
result.
which is we've got CFRG next. Probably this whole group will be there, and then Sec Dispatch. So great, Russ.
So we see work going on to adopt all these post-quantum algorithms using different protocols. But so far, we haven't figured out how to make sure that one crypto library will work for CMS, for COSE, for JOSE, for PKIX, and so on. And we really need to make sure that happens somewhere and that we're not forcing in some syntaxes fields that are returned as opaque values to be parsed in one and not in the other and that kind of thing. And I don't know where that's happening.
I don't think it is happening. Do you have a proposal for where, like how it should be started?
Here is a fine place to talk about it. I don't care where, I just care that it is.
Okay, can you start a document on just like even a bare bones, what are the requirements and such, and toss it towards the group?
I don't think so.
Okay.
Because the answer is whatever API you're using, make sure that it lines up with the fields. Oh, the fields then have to be coordinated across all those protocols. What else is there to say?
I don't know, but you were concerned enough to do it.
I was concerned enough to raise
I'm looking through the people in. Peter Gutman is not here, but I would propose that he would be a good person for this. So, yeah.
Good luck twisting Peter's arm.
I understand. You and I have had luck with that later. So we've got 2 more people in the queue. We've got 3 minutes. So Michael.
Yeah, just wanted to comment a bit on the test vector side. I mean, Open Quantum Safe, I know I at least put pointers in your original draft on the engineer side. I think those made it through, like, especially now that they've extended OpenSSL, particularly have a provider there, that's been really helpful. So like with the COSE drafts, we just rebuilt everything from a base test vector for inclusion in the drafts off of that. And so that gave us a really good path forward. It also gave us a way to validate that most of the people claiming to have JavaScript or TypeScript implementations out there were 100% broken, which was amazingly hilarious, actually, in a bad way.
To some people.
So, yeah, exactly. So, but this is the kind of thing I think Russ was getting at something important. I think it's more, we need a good, clear guidance, probably in the GitHub, or maybe a guidance for spec implementers, right? Not just for the engineers. Yep. These are things you need to look out for, because I think the rest of us have just kind of all called each other or bumped into each other here and learned the hard way. Like, oh, you're using LWE. Oh, you're using MLWE. Well, we haven't settled this out yet. Now let's, agree.
I propose that you, since you're closer than Peter Gutman is at the moment, throw together some markdown. It doesn't have to be long. It doesn't have to be a draft. Please do. Tom? Tom?
I just wanted to quickly plug again that
Yep.
there's a round 4 going, or not a round 4, an on-ramp for more signature schemes in the NIST standardization effort. And I'm sure that NIST will also be very welcoming people's input on what is submitted there. But I made a little tool that I sent over the mailing list earlier that you can use to compare these things. So I'll quickly plug that in the chat again. And then I'll plug a talk at the TLS working group later this week, where Bas Westerbaan and I are very quickly exploring all of these new submissions and sort of checking out what could be relevant for TLS, which even if you're not interested in TLS, you could sort of see how we use certain criteria to evaluate the list of submissions. And that's
great. Thank you. Great. And John, you have the last word.
Yeah, thank you.
Well, almost last word. Sophia gets the
yeah,
last word.
I just wanted to make a plug for the PQ and X509 hackathon, which we've just completed our third one this time. I think we've had up to 22 people that have participated. A lot of the work that we're doing is actually implementing a lot of these newer drafts, especially a lot of them coming out of the LAMPS working group, for instance, adding these new PQ algorithms into these protocols, keys, signatures. We just started with chems this time. We had some chems. So it's a good place to do interoperability testing, but also to make sure that things are actually working the way they need to work, right? So just wanted to, I know I've said this before, but it's a great team, and you're all welcome to join because we're a very friendly and open team. We're also planning to have an interim hackathon probably in September as well, just because there's a fair bit of work to do and just sorting these things out.
Will that be online or face-to-face or both?
That one will be online.
Okay.
Yeah, we're going to see if we can actually even maybe get the IETF to let us use the what is the system called?
The Metaco.
Yeah, well, it could be, or sorry, the Gather as well. If not, we'll do it over Zoom or
So
something.
let us know if it's a working group interim. I believe we get all of those things for a working group interim. Yeah, so we can make that a working group interim on hacking.
Yes.
Great.
Yeah. So
let us know. Sophia and I are happy to.
And a lot of the part of this group too is like we find things out, right? Like we did a lot of work with the composite signatures too, right? And we found some of these complications that we're talking about, right? So we're not giving up on anything. We're continuing to do that work, and it's actually it's a lot of fun too. So
great. Thank you. Sophia, take us out.
So thank you very much for coming to this working group. As mentioned, NIST is going to be having this new on-ramp call for the PQC signatures, but I will be a little bit careful at this point to actually start looking at those candidates. Just wait a few months when the actual round 1 candidates will be announced. And with that, I guess that's thank you for coming. And again, session was recorded, and thank you for the note takers.
Thank you very much. Thank you, Roman.
Thank you, Paul. See you.
Hey, Nalini. How are you? A little bit exhausted, but okay.
That's right.
Yes.
Dead, but fine.
Yes.
Let's sit down some point if you want to, because
on which topic?
Let me get to that.
Yes.
So we formed a nonprofit.
Oh, I heard about this. I mean, I only heard vaguely about it, but by the way, we're on mic, so.